Hello everyone, my name is Peter Schakner. I am the Managing Director of Schakner Electronic GmbH, and today we're going to optimize a Scania Torpedo T. Very briefly about today's procedure. Today we will now measure the Torpedo 730, just a little bit about the process. This is a DC 1603 engine, 730 horsepower, originally 3,500 Newton meters of base torque. It has an Opticruise OPC transmission, so a TMS gearbox. Today we will also program the truck using the app. As you know, we've developed a new app for Apple, and today we'll be going through the entire process with it here. My new employee, Bastian Sauerwein, is already here with us today. He will be helping to secure the truck here in the new workshop. As you can see, today we're filming the first video at the test stand in our new hall. It's about time that everything finally works. As I said, we'll get started in a moment. But first, a couple of things about the truck itself. It's a converted model which was modified in Holland. This particular design, as it is, no longer exists. I would say this is the top class of trucks. As you know, these bonneted trucks cost quite a lot of money. You can see the frame cover at the back. It's really an awesome truck, and I really like it. As I said, it's still lacking a bit in performance and fuel, as the customer mentioned, but we'll get that sorted out today. Let's see. My colleague is here, so everything's set, and Sauerwein is ready too. Let's take a quick walk around now. Based and I are going to unstrap the truck back here now. As you can see, it has a bogie axle. We're going to measure in 4WD, so we'll synchronize the axles again. Just as I mentioned earlier, we'll keep the bogie axle lifted at the back, so as I said, we can measure with a road simulation again. Now we're going to strap it down at the back, down here into the pit, right at the hydraulic cylinder. Basti is already taking care of everything now. As I mentioned earlier, since he has only just recently started working with me, we will be taking turns with the measurements so that he can learn and understand everything as quickly and thoroughly as possible. This is important because here in Großrohrheim, he will primarily be responsible for managing the truck test bench and will need to handle all related tasks and responsibilities. So, I would suggest that we get started now. We just tilted the hood again for a brief moment. Before we proceed, I want to explain a couple of things to you about the engine. It's a V engine, as you can clearly see, and located right up here is the engine control unit. In the past, before it was possible to do this via the app or through the OBD interface, we actually had to physically remove the control units from the engine. This engine is equipped with a variable turbocharger, as well as a two-stage exhaust gas recirculation system. The newer Scania Huns, for example, have gone back to using a standard turbocharger. Many people often say that the variable turbocharger is not very good because the guide vane adjustment mechanism tends to seize up over time, but from a torque perspective, that's simply the way it is and how the system operates. The variable turbocharger is just absolutely incredible. It really, truly pushes, especially at low revs, and brings in a completely different kind of air, a new quality of airflow that you can really feel. For us, when it comes to programming to save fuel, it's just fantastic, honestly. We can optimize it perfectly just by increasing the torque without making any changes at all to the boost pressure, which is a huge advantage. Of course, the exhaust gas recirculation always causes some issues with trucks, especially since it has a two-stage EGR with a sliding cylinder. That's a bit of a weak point in this engine, something to keep in mind. But knock on wood, I have a lot of customers who have well over 1.5 million kilometers on these, and so far, pretty much without any problems at all. Engine damage is basically unheard of in these trucks, which is really impressive. So, as I said, even in terms of base torque, let's just see what it actually delivers in the initial measurement, which is always interesting. With the 730, we have quite a bit of engine variance, more than you might expect. For example, we've measured the old Euro 5S at only 650 horsepower, which is quite a difference. So, as I said, let's just see what comes out in the original measurement and compare it. Basti has now strapped down the truck so we can walk around it again briefly and take a closer look. You can see back here we have the lashing eyes in case we have trucks that are longer, where the rear overhangs further back, which can be a challenge. We can lash them crosswise here, which helps with stability. You can see here it's crossed over and strapped down cleanly at the back, so it's really tight and secure. During the measurement, the truck pushes forward against the roller, so we hold it back at the top, and at the bottom, with the hydraulic cylinder, we pull it down into the roller with about 4 tons, and then again to the rear, making sure it's firmly in place. We did the same at the front, also cross-strapped, so it stays in line and can't move left or right, which is crucial for safety. That's always extremely important, so that if something were to break loose or whatever, everything is double and triple secured, and nothing can go wrong. That's why you really have to be careful and pay attention to every detail. Now, with this truck, we're going to change the final speed, which is an important step. We'll do the WD measurement in 11th gear, in direct gear, which gives us the most accurate results. With Scania, you always have to check. If you have an overdrive transmission, sometimes the 12th gear is the direct gear, so it's important to verify. So in this case, we're measuring in 11th gear, as that's the direct one. We're now increasing the final speed to 160 or 180 kilometers per hour. We'll have to see how far the revs go depending on the engine's response. We'll measure again from the bottom, 800 up to 2,200 or 2,300 revolutions per minute, covering the full range. We'll set that up and work it in cleanly. Then we'll get started with the actual test. Now we're setting the final speed and we're starting the first baseline measurement, which will give us a reference point. You can see here we have the laptop. The TV isn't here yet. We'll install that next week. So for now, we're using just the laptop. The speed has come up. I'm just warming up the tires a bit more, making sure they're at the right temperature. I can control all of this via the laptop now that we've plugged in the cable, which makes things much easier. So let's do the first baseline measurement and see what numbers we get. It's important on the test bench that the tires are warm enough so we have traction, because with the 3 Newton meters the truck is rated for, it can happen that it slips on the roller if, for example, it's wet or the tires are too cold, which would affect the results. We really need to have 100% grip on the roller, no exceptions. So I'll start it now, turn off traction control, everything, so it doesn't start slipping anywhere or electronically braking us, which could interfere with the measurement. The front axle is spinning now. You can feel that the V is already a bit restless when accelerating hard. It's got a lot of power and you can really sense it. You notice it more on the test bench because on the road you still have bumps, but on the test bench you feel every single shift, every change in speed. Now you can see it, we're accelerating up, going into 11th gear, and now we're basically revving it all the way out to see how high it goes, pushing it to the limit. Now we're over 90, you can see we still have air. Now we're already at 110, up to the max rev, and it's still pulling strong. You see, it revs almost up to 140 in the highest gear, pretty much 140, which is impressive for a truck of this size. You can see it clearly on the display. Of course, you can't drive that on the road. The legal speed limit is 89 or 90, EU standard speed, so this is just for testing purposes. But on the test bench, we need it for the measurement because we're in direct gear and we have to rev it all the way out. Otherwise, it won't show us the power loss correctly at the end, which is what we're trying to measure. So now I'm going to synchronize the RPM here again to make sure it's exactly right. I'm trying to hit exactly 1,000 revolutions per minute. There, exactly 1,000. Now the axle is synchronized, so I have the exact RPM reading. Then we turn on the fan, that's the blower in front, so we get fresh air and the engine doesn't start to heat up, which could distort our measurement results. And then we'll start the first measurement. So at this stage of the process, what I am doing is using 800 revolutions per minute as a reference point. The reason for this is that the LCKEW motor already produces a significant amount of torque, even at low RPM, which means it is perfectly acceptable to take measurements at a slightly lower speed than usual. Now the next step is to allow the system to brake, and as we do this, we begin to build up torque gradually. This is the point where we actually start the measurement process. As the test continues, the motor revs up, increasing its speed until it reaches the maximum RPM. Once it hits this peak, We then let it coast down naturally. During the acceleration phase, we are specifically measuring the torque output, while during the coasting phase, our focus shifts to measuring the power loss that occurs as the system slows down. You can observe here that as soon as the motor spun out, the measurement became invalid. This happened because I shifted out of gear too late. In situations like this, we can simply discard that particular measurement. This demonstrates that, as you can see, things do not always go perfectly on the test bench right from the start. For example, at the top of the RPM range, the motor spun out because I was a bit late in shifting out of gear, which affected the measurement. These kinds of issues are part of the process and help us refine our testing methods. I went into neutral, so normally when you do that, the curve on the graph should drop down here, indicating that the engine is no longer under load. Let's go ahead and delete that particular data point now so we can keep our measurements clean and accurate. Once that's done, we can immediately measure again right away without any delay. So we're going to follow the same procedure as before, repeating the exact same steps to ensure consistency in our results. Let's see what happens this time. Now it's working properly and we're finally getting a nice clean measurement. You can also see, and maybe at some point I'll even do a live stream of this process so you can watch it in real time, that it actually takes me quite a while to shift out of gear. This is something you might not notice unless you're watching closely, but it's an important part of the process. Here, you can see on the display we have an input power of 710 horsepower, which is a substantial amount, and 3,672 Newton meters of torque. That's actually 100 Newton meters above the stock value, which is really, really good and shows that the modifications are having a positive effect. I mean, we are about 20 horsepower short of the target, but the torque is just brutal, really impressive. Down here on the graph, you can't see it so well in this area, but the engine reaches its maximum torque at pretty much exactly, I'd say, 1100 RPM, and it manages to hold that maximum torque for a short stretch, probably up to around 1350 RPM, and then it already starts to drop off again, as you can see from the curve. At higher RPM, for example, if you look up here at 1800 RPM, it only has about 2700 Newton meters of torque left, which is a significant decrease from the peak value, and that's what we're going to try to adjust now, because that's the main input issue we're facing. Let's see where we end up after making some adjustments. We're going to flash the truck now using the app, which is a process where we update the software to optimize performance. In general, we always do another measurement after flashing. Actually, we do 2 more measurements to be thorough. We always perform 3 baseline measurements before making any changes and 3 post-flash measurements after the update. So you can really rule out any tolerances or inconsistencies and have 3 reference measurements for a clean, reliable result at the end. Okay, so we'll go ahead and do the remaining measurements now, and then we'll see each other again when it's time to flash the truck. We're going to flash the truck now with our new app, because as I mentioned earlier, if you have a Mercedes and the current E-model, you can already do this yourself. Here you see the OBD dongle again, which is the device that goes back into the car's diagnostic port. And then you just use either an iPad or an iPhone, whichever device you prefer. What matters is, as I said, that it runs iOS 15. Then we can already reprogram the truck using the app. So let's get started with that process. I also built myself a custom adapter here in between, so you can see the connection better. I plug it in up here at the OBD connector. They're set at an angle, and after years of use in the workshops, these connectors are not always in the best shape anymore, which can make the process a bit tricky. But with the adapter, it becomes much easier to handle and observe. So let's just plug it in right over here now. Oh. Now you can clearly see the LED lights down here, and Bluetooth is also currently active. Then I'll come back over here. So now we basically open the app here, just the regular Schnee electronic Schaknat flasher. Now I see here, once Scania and once Mercedes. So now I go to Scania here, go to the Bluetooth settings. So settings, look for my OBD link here, that's this one. You see it actually connects pretty quickly, and as you can see, it's already connected. Now I go back, just open the app again, and now you see it has already automatically recognized the dongle, and it has already detected the chassis number for you. Whoa. So now you can tap on the chassis number here and assign the license. Now I've just entered a sample license plate. It's a Scania T-bonnet truck. I've already assigned it, and I can just change the fields here depending on what I have. 1, 2, 3, 4, just click next and it will already save it here. Then we'll go back one step. Now I can see here that the engine control unit and the transmission control unit are already stored. So now we'll go ahead and select the engine control unit. Now here I have the option to either reset to factory settings or to flash the eco optimization. Now we'll measure both the eco and the power optimization depending on what the customer wants. Of course, at the moment, I've also spoken to my customer. He has a very high fuel consumption. Personally, I'm always more of a fan of the eco optimization because, as I said, the cars run more reliably and last longer. The eco optimization also delivers great performance and excellent torque, but we'll see that in the measurements in just a moment. And then down here, I have the option to code the engine control unit again. These are still special codings for us, which we've developed for the cars and which we always specifically adjust. All right, now we're going to flash the eco optimization. Now you can see the progress bar is already running. It goes relatively quickly because we've only set the partial areas, specifically area E, so you're really just flashing the pure data set that contains the important key fields for us, like torque, end peak times, end peak quantities, and depending on what we need at the moment, we only flash that specific area. You can see, that's why it goes pretty fast. It takes about 1.5 minutes at most, which is quite efficient for this kind of process. The important thing to remember is not to start walking away from the truck or take a phone call while it's programming. Hands off the phone so it doesn't go into standby mode, so the process completes cleanly and without interruption. Now we're already at 80%, it's almost done. Of course, it took a long time for us to get it to work this quickly and easily, and there was a lot of development and testing involved. Now you heard it, click, click. Now the control unit has reset once, and it's basically already finished. Now you could turn off the ignition, but we don't want to do that yet because there are still a few more steps to complete. We also want to code the transmission control unit and engine control unit with our special parameters, which are tailored to our specific requirements. So now I'll just go here and code the engine control unit again, making sure everything is set up correctly. Now it goes quickly again, click, click, or it's already done. That was now an EMS 8 engine control unit. That's still the old streamlined Euro 6 A and B technology, which is a bit different from the newer systems. The newer ones have EMD, depending on the control unit variant or what we have. The coding is always a bit different and we have to adjust accordingly. Now I can go back one step. I mentioned last time that there will be an update down here with error memory deletion and then transmission adaptation. That will come in the next update, so stay tuned for that. But now I can go here, transmission control unit, the OPC5, and optimize the transmission again, making sure it's running as efficiently as possible. It's the same thing. We've developed certain parameters over time for how the transmissions run best, so we've called that transmission optimization as a general term, which covers all the improvements we've made. So now we'll select Optimize Transmission. Click, click. It's already reset the control unit again, so it's basically already worked, and the changes have taken effect. The whole process, when the data sets are stored on our servers according to the chassis number, as you saw, that was a matter of 3 or 4 minutes, which is quite fast considering all the steps involved. And the nice thing about the app is, if I have a maintenance contract, I can always go back and restore the factory state before I go to service, which gives me peace of mind and flexibility. We can maybe show that again later if there's time, to demonstrate how easy it is to revert to the original settings. First and foremost, the customer can freely choose whether they want eco mode, power optimization, or the factory default state. All right, then let's see what happens. Let's do the measurement and then, for a moment, take a look. So we've now measured the first eco optimization after flashing it, and as you can see here, originally we had 710 horsepower and 3,627 Newton meters, and with the eco optimization we already have 842 horsepower and just under 3,900 Newton meters. So as you can see, in my opinion, that's already more than enough. But the customer wants even more, so as I said, we're going to take it up a notch. He wants to have the second variant measured as well, so I'd say we'll quickly flash it again with the app and then we'll immediately start the next measurement. So as I mentioned earlier, we're now going to proceed to quickly reflash the system. You can see right here, we've plugged the OBD connector back in and the Bluetooth connection is on again, just as before. I'm now going back into the application on my device and I've selected SCE once again. From here, I go to this section, reconnect the dongle, and then return to the app interface, where it automatically recognizes the dongle once more. As you can see, it's already detected all of the control units and everything is already stored in the system memory. Now, we go to this option and can immediately flash the power optimization feature right away. Let's proceed and do that now. You can observe here that all the engine error messages pop up on the screen, but that's completely normal and expected when you're flashing in boot mode, which is basically like a sleep mode for the system. All the control units will throw error messages during this process, but once it's finished, the errors disappear because the control unit resets itself once. But as you can see, it's super quick again, so we can immediately proceed to do the next measurement. It's also a very fast and simple solution, especially when we're developing something new and have several different data sets already stored online. That way we can quickly reflash on the test bench and test things much faster and more efficiently. So actually, I think it's a super simple thing in itself, and I want to take a moment to explain why that is. Like I said before, this is also the future. Everyone has a smartphone these days, and with that, everyone has access to a wide variety of apps. It's become so common that almost everyone, regardless of age or technical background, can use an app these days. The process is really straightforward, and it's a great solution for making things easier and more efficient. So, as you can see on the screen, all the errors are disappearing again, which means the error list is now completely clear, perfect, just as it should be. Now that everything is in order, we can already move on to the next measurement without any issues. I'll go ahead and close the app again, and that's it for this step. Then we proceed to the next measurement. Now I have a customer here with me, Felix, who has brought his Hauber truck. As I mentioned earlier, Felix, you have a very nice truck. It's an absolutely awesome machine, and it's always a pleasure to work on such a vehicle. We're all set now, so I'll quickly show Felix the measurements again so he can see the improvements for himself. So take a look, Felix. Here we have the original measurement, 710 horsepower and 3,627 Newton meters of torque. That's already impressive, but today you're getting the app from me, and on the app, I've set up the standard power for you. This includes the eco optimization, which brings the truck up to 842 horsepower and 3,882 Newton meters of torque. That's a significant increase in both power and efficiency, which should make a noticeable difference in performance. And because you have a Hauber and it's a show truck that stands out from the rest, you're actually the first truck at our company where we've managed to break the 1,000 horsepower mark. That's a huge milestone for us and for you, Felix. So, as I said, we now have 1,004 horsepower and 4,086 Newton meters of torque. It's really brutal. On the test bench, it was quite a challenge to measure such high values. The eddy current brakes we used are brand new, and you could really see that the system was under a lot of stress, with a lot of smoke coming off during the test. Of course, there's still some paint on the brakes and other components, but they really had to work hard to handle the power output. So, as I said, Felix, that's the app, and you'll get a TAN for your phone, which means you can always flash the software yourself whenever you need to. This gives you full control and flexibility over your truck's performance, and you can make adjustments as needed right from your own device. The high power version that we are talking about here is these 1,004 horsepower, which is an impressive figure, and you can flash it back and forth as needed, depending on your requirements, whichever works best for you in your specific situation. We also took the time to optimize the transmission at the end of the process. I did that separately on the laptop, working carefully, and individually adjusted the transmission for shifting comfort so that it works smoothly and seamlessly when maneuvering, driving, or reversing, so the shifting is really easy and comfortable. As I said before, make sure to always keep the dongle safe. Don't break it or lose it, as it is very important. And I have a little something for you, a Hugo Boss air freshener from the company Schaknat, which we now always give to our valued customers as a small token of appreciation. Here you go, please accept it. And as we've known each other for a long time, look here, the jacket, unfortunately, he got it dirty, but it's a soft shell jacket from us, our company. You'll have to wash it anyway, so try it on and see if it fits you well. The 1,004 horsepower jacket fits perfectly, everything's good, perfect. So, as I said, I hope you're happy with our results. I think you are. And that makes me happy as well. It really is a beautiful truck, a truly impressive vehicle. This was the second or third major measurement we've done on our test bench, which is a significant milestone for us. I have a lot of respect, especially when we measure trucks with this kind of power, so I told my colleague Basti that we really have to make sure everything is properly secured so nothing goes wrong during the process. But as I said, it all worked out perfectly, 100% without any issues. And now finally we have our 1,000 horsepower truck, and it's even a Hauber, which is quite special. So thank you, really great. Glad you tuned in again to our video about the Scania Hauber TDC 1600 engine. It was a huge pleasure today, especially measuring this kind of high power, because it's not our everyday business. It's something extraordinary for us. But as you can see, we can handle these kinds of things too. We are up to the challenge. Of course, this isn't approved for road use under the SCVO, so please keep that in mind. Such high power is really more for show purposes, for trucker meetups and similar events like that. However, as you can see, we can also absolutely handle these more specialized projects. Of course, our main focus is still on fuel savings, but as I said, the customer wanted it this way for show purposes, and I think he was more than happy with it. As mentioned, if you're interested in this topic, feel free to check out schaknat.de. If you have questions about fuel saving, software, performance optimization, or transmission optimization, we're always happy to advise you in a personal conversation. Just send us an email or contact us via WhatsApp. It was a huge pleasure. Feel free to check us out again. See you next time. Bye.